Hi everyone. Today we have complete course of Numpy library. Numpy stands for Numerical Python. It is an open source Python library that provides support for large multi-dimensional arrays and matrices. Numpy is incredible, versatile and is used in a wide range of applications like numerical computation, data analysis, machine learning, scientific computing, image processing, signal processing, and many more things. We will cover all concepts of NumPy library like introduction to NumPy library, what is NumPy, why we use, how to install it, creating NumPy array, indexing, slicing, advanced indexing, NumPy data types, NumPy array shaping and reshaping, how to iterate NumPy array, join, split, search, sort, filters, compare, union, and how to find unique rows in NumPy array. So let's get started with the complete course of NumPy library. NumPy is a Python library used for working with arrays. It also has function for working in domain of linear algebra, right? And metrics. Okay. It is open source project and you can use it freely. NumPy stands for Numerical Python. Now the question is why we use. Okay. In Python we have list, right? That serves the purpose of array, right? You know the list. So we use list like this, right? So this is the list in Python. So this list in Python is very slow to process, right? The array object in NumPy is called ndarray. So it provides a lot of supporting function that make working with ND very easy. Okay. So the other most important benefit of NumPy is it stores the array at one continuous place in memory, unlike list, right? So processes can access and manipulate them very efficiently. This is the main reason why NumPy is faster than this list. Okay. Also it is optimized to work with latest CPU architectures. Okay. However, NumPy is written partially in Python, but most of the parts that require fast computation are written in C or C++ language. If you want to see what is NumPy, there is a website numpy.org. This is fundamental package for scientific computing with Python. Okay, and latest release of NumPy is 1.26 version. Right, you can see all the releases, all the versions. You can check out the documentation also. Okay, if you want to see how we can use NumPy, how we can install it, you can see those information easily in this website, right? This is the official website of NumPy. It is free to use. It is open source. Okay, API references, contributions. If you want to see how to install NumPy on the machine, so you can find those information also. You see there is a pip. If you use pip, you can install NumPy with pip install NumPy. Okay, on our machine, we can easily use this command on the prompt. Okay, our command prompt, and with help of pip, we can install NumPy library. Okay, now let's see how to install NumPy on a machine. This is PyCharm editor on my machine, right? I have a terminal over here. If I click over here, so the terminal would be starting here. On this terminal, if you want to see whether pip is installed or not, then you have a command to check, because with the help of pip you can install the NumPy, okay, or other library packages for your purpose. Okay, so my terminal is on now. Okay, we will try to see whether pip is installed on our machine. My command prompt says I'm in e demo python, so there is a pip hyphen hyphen version. Okay, so this command will tell us whether pip is installed on this machine, on this environment. Yes, pip 23.3 version is installed. If you want to see whether the NumPy libraries is installed on my machine or not, so you have to check list. This is the command to see whether which libraries are installed on my environment, on my machine. So you will find the list of total libraries, right? You see NumPy is installed. Okay, pandas is installed. So what I will do, I will uninstall it first and then I will install it. But before that, if your machine does not have the pip, okay, then you have to install. To install pip, you have to go to this website, right? And you will find the installation steps here. Okay, If your system does not have pip installed, so you can go and you can follow the step and pip will be installed, then you will be able to install NumPy library on your machine. Okay. However, NumPy is installed on my machine. If you see, it is there. So first I will remove it. Why? Okay. It is saying you want to remove. I will say yes. Yes. So it will remove 1.26.1 version. If you see pip list, we will check our library on the system. So it will not show you NumPy. Okay. You see it is removed now. Let me install it again. Always it will download the latest version, right? If you do not specify any version here. Okay. So I am just press entering without the version. So it will get the latest, okay, of this version. You see, NumPy is getting downloaded. Previously it was 1.23. It is collecting the package from the source. Okay. From where it is collecting? So it is collecting the packages from py.org. Okay. So this is a source of packages. If you find any of the library, you can search, let's say NumPy. So it will show you the NumPy version. You see 1.26.2 version that is installed on our machine now. It took from here. Okay. The NumPy is installed on my machine. If you check again the list, you see NumPy is now visible. Okay. 1.26.2. This is the latest version. Let me close it down. Now other step using NumPy library. Okay. We have installed the NumPy library on the machine. We have to now use it. Let me remove it. So we have to first import NumPy. You can see the package and we will be creating a simple array. In order to create array, we have to just say a1 equals to numpy, that is our library dot array. We have to say, you see, numpy dot core dot multi array, right? So I am saying this would be my array. These are items of my array and we can print it easily. Even if you're in the program, so you will see the array is printed right here. Okay. If you want to create an alias of the library, so you can make it easily. Let's say as n, I want to put, so instead of numpy, you just say n, say alias, and you can still use all the functions from this library. Okay. The output is same. If you want to check out the version of the numpy, you can check it from here also, right? From the Python code. Let me take print and you say n dot version would be there. I believe so. Version. Yeah, version we have. Okay. So you can get the version name also, which version of NumPy we are currently working with. Okay, 1.26.2. This is very basic point of starting with NumPy library. Guys, in this video, we will be learning how to create NumPy arrays in Python. But before that, we have to see how we can create array using list, right? So array are used to store multiple values in one single variable. Python does not have built-in support for arrays, but Python lists can be used instead. If you see array, so this is a list, right? If you want to print the list, so what we'll do? So for, so this is what? This is our array, you can say, in form of list. Either you can use list or we have one module in Python that is array. So just import it, array module. If you want to create an array, let me take one this time, dot arrays, right? We are saying it's a integer type of array. Okay. And then we are specifying our items. Okay. These are our items. So if you want to print this array, so what you have to do, you have to apply I in 3. Okay. Then it will come and we will be saying print, leave the space. So 2, 4, 5. Okay. Here we have to discuss what is NumPy arrays, right? How we can create NumPy arrays, how we can create ND arrays. Then we will see how we can create different dimension arrays like 0 dimension, 1 dimension, 2 dimension, 3 dimension, and then higher dimensional array will be looking. Finally, we'll see few function from NumPy arrays. Okay, I'm going to import a NumPy. Let me remove this code. Okay, now let's create a array using numpy. Okay, we have to import numpy and we are taking alias, let's say np. Okay, and then we are saying array1 equals to np dot array we have to use, right? Array we have taken and we have to pass elements in form of list. Okay, so this is our list, and if you want to print what is type of this object, so you will get to know, okay, what is this type of array, the object, right? So this is the array we have created. Okay, so this is the type of this array object. Okay, it is referring and the array from numpy, right? So numpy actually is used to work with arrays. So array object is numpy is called ndarray. Okay, always remember we can create a numpy ndarray object by using the array function. Okay, this ndarray we retrieve through this array function. Okay, this function comes from numpy.core.multiArray class. Okay, so to create ndarray, we can pass a list or tuple. We can even pass if you want to pass tuple. So you can pass it also. Run the program again. So it will still show you the type of the array as ndarray, right? However, you have using tuple, but it has converted your tuple into the ndarray. Okay. Let's see what is the dimensions of array. A dimension in array is one level of array depth, right? Nested array, you can say. Okay, nested array are arrays that have array as their element. So what is zero dimensional array? Zero dimensional array, it's could be a scalars, right? If you want to print and you say np dot array, okay, and you put let's say 30, okay, and you print array 2, so it will, if you're in the program, so it is zero dimensional array. Okay, only one element is there, right? So we say it's a scalar, right? Zero dimensional array, and each value array is a zero dimensional array in this object. Okay, you will get to know this is a type of same class, right? ND array object. Let's see one dimensional array. So one dimensional array you have already seen. Before that we have passed these elements in form of tuple or list. So this is a single dimensional array, one dimensional array, you can say. Okay, what is two dimensional array? Array that has 1D array as its element is called a 2D array. What does that mean, right? Means a array containing another array as a element, right? Let me take array 3. Okay, there is another array. Okay, you know the first element of the array is containing another array, so we can say this is a two dimensional array. Okay, if you print array 3 type of array 3, so you will get the output like, okay, so maybe we have to make it as a other element, we have to make it as a whole element should be in the dimension, right? When we are using two dimensions, so it means all elements should be two dimensions. We cannot say like another third element of this main array, first dimensional array, we cannot take single, right? It will give us the error, right? Okay, you see, setting an array element with a sequence, the requested array has been in homogeneous shape, right? After one dimension. Okay, so this message is clear. Okay, we cannot do it like this. We can even make it array, right? Another array, okay, on this element position. You run it, so it will work. Okay, like this. Yeah. Okay, got it? So the first element of the one dimensional array is this. Second position of the element this array. The third position is if you want to check three dimensional array. So how you will create three dimension? So let me take another example, 4. Okay, so we'll take it 4 and 4. For third dimensional, you can put it, and this is closed, and this become closed. Okay, so this is now converted to the three dimensional array. You see, okay, okay, you see, it is three dimensional array. If you want to check what is the dimension of the array, so we have one function so that you could check array 1 dot ndim. So ndim we have the property which actually gives us the dimension. What is the dimension of the array, right? Array 2, array 3, okay, and then array 4. So all array you will get to know what is the dimension of these objects, right? So you will get 1, okay. If we say this is the array 1 is our one dimensional array, and array 2 is a zero dimensional array. Array 3, that is our two dimensional array, okay, and array 4 is our three dimensional array, right? So here we can clearly see how we can get the dimension of the array. Now let's see higher dimensional arrays. What is higher dimensional arrays? An array can have any number of dimensions, right? When the array is created, you can define the number of dimension by using the ndmin. Okay, ndmin argument you can use, and we can define our dimension on the array. Okay, which dimensions it could be created. So if you take the example of first, we take one, okay, control C, and then I'm putting as a list, okay, you can put anything, and we have one and the min, okay. This argument we have here in array, and we can say it could be three, okay, it could be three dimension array. Then let me take 5, 5, 5, okay, let me run the program and then see what will the output, okay. So you see, so it created three dimensional array, okay. So three dimensional array you see, so how it created, right? Three dimensional array was created like this in the same format, right? Okay, there were three items. If you want to make it one dimensional array, right, so it will create one dimensional array like this array 2, okay, one dimensional array like this, okay. So here you can define, okay, which type of dimension you want to create with array, with this array function from numpy module, okay. So we have covered high dimensional array we can easily create. Now let's see a few numpy methods, how we can get the advantage from those methods. Let me remove it, okay, this one, and let me run it again, okay. Okay, so first function that we have, that is numpy dot empty, right? So numpy offers several functions to create array with initial placeholder content. So this minimize the necessity of growing array, right? Okay, so for example, like this np, you see zeros, or np dot empty, right? So this we can use, right? So what is the parameter for this method? Actually this takes the shape first as an argument, then second it takes data type, it could be integer or float, and order equals to whatever c, right? Returns a new array to give shape, type, and with random value, right? So if we take empty array from empty, and I'm saying that could be, let's say my shape could be 2, d type would be, let's say, integer type. So if you print array 1, so it will create you the empty array. This is two dimensional array, yeah, this is two dimensional array I'm saying, okay. If we want to create 3, 3, so it will create you two dimensional array as a, but those are the random numbers, right? It took, okay, 3 3, the matrix is 3 3, okay. You see the matrix is 3 3 inside the array, okay. So this is the purpose of empty. You can create empty arrays anytime. You can define which type of matrix 3 by 3 you are going to put, okay, and you are saying which type of data it should be carrying with, okay. So that is first method. If you talk about the zero method, so let me take array 2 equals to np dot 0, okay. So here we have again shape, data type, okay, and the order, right? We'll be taking, let's say, 2 as a shape, okay. So it will create 0, okay, inside the matrix. You see 0 0, right? This is the one we have seen, two elements create 0 0, okay. If we say it should be 2 by 2 matrix, and it will create you 2 by 2 matrix. Okay, a two-dimensional array and 2 by 2. Okay, let me take 3 this two-dimensional array with. There are so many other methods. If you want to try, we have arrange method, reshape method. So if you want to use, you can try yourself. Guys, in this video, we will be learning what is intrinsic NumPy array creation functions in Python. NumPy has over 40 built-in function for creating arrays as laid out in the array creation routines. These functions can be split into roughly three categories based on the dimension of the array they create. First is 1D, one dimensional array. Second, 2D array, two dimensional array. Third is ND arrays. So we'll be talking about 1D array in this tutorial. There are two functions, right? One is arrange function. Second is linspace. So these two functions will covering in 1D array. Okay. In order to use NumPy, we have to say import numpy. I'm creating alias np. Okay, so this is the one thing we are going to see. What is numpy arrange method? Okay, so numpy arrange method is nothing but it creates array with regularly incrementing values. So let me create a variable array1 dot arrange. We have to specify the value of the argument, that is for how many elements you are going to create. Okay, if you print the type, right, so you will get to know which type of object it is returning, and then finally he'll be printing the output of the array. If you run the program, so you will see the output. So the type of the array which arrange function is returning, that is ndarray. Okay, and the elements in the array which we have in the object are 0 to 9. Okay, so we have specified 10, so that's why 10 elements are created in the order. If you specify any other number, it will use. We want to specify till 5, we have to arrange. So you will see 0 to 4. Okay, we have other arguments also. If you want to start your array with a specific number and you want to stop it with a specific number, then you can also use this thing. Okay, so let me copy the code, and this time I am taking variable 2. So I am going to start my array from 2. I want to stop it on 10. So it started from 2 and ended, before 10, means total these elements would be creating. We have, say, this is start and this is end. Okay. If I want to say, okay, my interval would be, 3, or it would stop at 50. So the array would be starting from 2 and it will take interval of 3 and it will be stopped at 50. Okay. So if you run the program, so you will see it started from 2, it took interval as 3, 2, 5, 8, 11. Okay, and then last it ended before 50, right? Okay, we have one more argument here. If you want to specify the type of the element, so you can also specify the type. And if I wanted to say it should be float, so the float elements would be creating. Okay, the 2 to 5, I want to take interval 3, 2. Okay, I'm taking zero point 0.1 as a interval. Okay, then it will create many elements, right? You see 2.2.1, 2.2, 2.3, 2.4. Okay, so we have seen the data type we can change anytime. Okay, float, integer, anything we can take. Okay, so this is the advantage of arrange function. We can create these type of array easily. Okay, with help of numpy library. Now let's see what is numpy linspace. Okay, linspace will create arrays with a specified number of elements and spaced equally between the specified beginning and end values. Okay, array 3 as a variable, and I'm going to use np dot linspace. Okay, so this is the function which we are going to use. Start is 1, stop is 10. This third argument is for how many samples we are going to create. Let me take the 5 sample. So it will create 5 sample. Okay, 3, 3. Let me run the program. it created 5 samples, 5 element, 1, 2, 3, 4, 5. Okay, this is starting, this is stopping point, it was the interval, but here it is the samples, number of samples, how many elements we are going to create in this array, right? So interval it will create automatically, right? If you see the documentation, so we have start, okay, we have stop, we have number, okay, the number which I'm talking about, this how many intervals, okay, line space. So if you see here, so here we have start, we have stop, means when we are going to stop, okay, num, it will show you this is a parameter. The num is number of samples to generate, okay, default is 50, okay, default is 50. If we leave it, so it will create 50 elements, right, 50 samples, right? So this is what the purpose of endpoint means. Endpoint would be true means it will end on the stopping point. If we are saying endpoint, let me close this documentation. Endpoint, let me say true, which means it will stop at the stopping point, right? 10. Here is the default is 10. Let me take number of samples 4. Then it will take last point, last element is 10. Okay. If you observe, the interval is different, right? But the endpoint we have passed on true, it means it will be equal to the stopping point, stopping element. Okay. If you I make it false, by default it is false. So you will see element was not the last one. Okay, in the sample, in the last sample. So that is the difference. Okay. There is one more. If you see the documentation, we have this rat step. What does that mean? Rat step. If true, where step is the spacing between samples. Okay. If you, let's say, if you see endpoint true and rat step true, which means it will actually returns you the excluded element, right? Means 3 was not taken in the interval, so it excluded this last sample. Okay, and the output is different. You see, the output is different for this ret step argument. If I make it true, okay, if I make it false, by default it is false, so it will give you the same output as it was previous, right? 10 in form of array and the array. Okay, so you can see the documentation on NumPy official websites. There is a documentation, you can use it. However, arrange and linspace functions seems similar, but there is a difference. If you want to create array on interval basis, you can use arrange. If you want that how many elements with automatic interval and you want to create your elements on your desired number of samples, then you can use linspace. Okay, we have also endpoint rat step here. Here we have d type also, right? This, so I have make it int, so it will create all element in int. Okay guys, in this video we will be learning what is intrinsic numpy 2D array creation function in Python. In last video we covered one dimensional array functions wherein we discussed two function arrange and linspace. NumPy has over 40 built-in function for creating arrays as laid out in the array creation routines, right? So these function can be split into three categories, like you have seen 1D array already, 2D, two dimensional, and then ND arrays. Okay, we are going to see this function one by one. So numpy I function defines a 2D identity matrix, right? The element where I equals j, these indexes values are 1 and then rest are 0 in the matrix. Okay, if you want to implement it, numpy alias of numpy array1. Let me open the documentation of I function. Okay, so you will see these are the arguments of I function and this is the information about this function. So if you see n, what is the first argument of this method? That is number of rows in the output, right? Let me take 2, number of row I want to display 2. Second argument, what we have? We have number of columns. Okay, if you pass 2 into 2 matrix, Then we have to say the index of the diagonal, which index you wanted to start your diagonal elements. Let me take 0, and if you print array 1, and before that if you wanted to see which type of array it is returning the object, so you will get to know this is ndarray, right? Okay, so you will see this is ndarray, it is returning the I function. Okay, and if you see what is it is returning ndarray of shape n and m, right? Rows and columns. Okay, it is returning diagonal 2D array. Okay, right? So if you see, it is two-dimensional array. Okay, this is first dimensional, and then in this we have another array, right, as a element. So this is called two-dimensional array. That is, it comes in the two-dimensional array. And if you observe a diagonal element, that is one, right? Rest of the element would be zero. Okay, if you make 3 into 3 matrix, so you will get 3 into 3 matrix with diagonal's value would be 1. Okay, if you want to start your diagonal position with other index, let me take first. So you will see your diagonal index started with first position, not zeroth position, right? If you want to change the matrix 5 multiply by 5, then you will see the diagonal element would be still 1. Okay, and these are the diagonal values. Okay, so the purpose of I function to create diagonal elements with one value, rest elements of the matrix would be 0. Okay, if you see the documentation of this one, right, so we have d type also you can pass on. Let me take float. Okay, if you run it, we will get the float values, right? Okay, or you can see int, right? So we have one order also, that is one other argument. If you see the order, it would be C or F as a character. So if you provide the F, so it will order your elements in memory. Okay, asterisk we have, like we have. Now jump to our next method, that is diagonal. What is diagonal method? It can define either a square 2D array with given value along the diagonal, or if given a 2D array returns a 1D array, that is only the diagonal element. Okay, the two array creation function can be helpful while doing linear algebra. Okay, so how we can use this function array 2, and then you say np dot diag diagonal values this. Okay, let me take 4 5. Okay, so what it would create, it would create 5 into 5 matrix, and diagonal values would be 1 2 3 4 5. Okay, and then if we want to print, it will generate the matrix like this. You see, it is two-dimensional array, right? In this first element of the array, we have this complete matrix that contains the diagonal element as we have said. Okay, if you want to make it less, then it will create 3 into 3 matrix 1 2 3. Right, so in this function also we have which position we want to start our diagonal, right? One, start with first index. My diagonal values would be starting with first. Okay, so you see first, not 0. Previously by default it was on 0th position. So this is the diagonal function. Or if you want to provide any of your array, and I'm creating simple numpy array that is two-dimensional. Okay, we have defined it will return nd array again, and we'll be taking other array 4 variable, and would be creating the diagonal. Okay, we will getting the diagonal elements array. Okay, array 3 will be passing here, so it will return the diagonal array to us, right, in form of nd arrays object. Let me take array 4 as a output and then run it. Okay, So what would be the output? It would be the output 2 and 7. Okay, the diagonal array would be 2 and 4. If you want to print array 3 also, so you will get the matrix, right? You will get, if you see its documentation of diagonal, so you will get the information. So extract a diagonal or construct a diagonal array, right? So as I said you, so it will extract a diagonal and wish to write to the resulting array, right? So we extracted diagonal matrix, okay, from here. So you can see more information over here and you can use it, you can try it. Okay, let's see other method, that is vendor method. It defines a vendor monde matrix as a 2D numpy array, right? You know vendor monde matrix, it is nothing but it describes the linear algebra interpolation program of finding the coefficients, right? What it does actually, each column of the vendor monde matrix is a decreasing power of the input 1D array or list or tuple, right? So let me show you array 5. Okay, this is my array np dot vendor. I'll be passing a list over here and give me the 3 or 2 or any column output. Okay, this is, and then we'll be printing array 5. Okay, let's in the program. So you will get to know what it is doing. It is actually giving us the number of columns we have provided, and it is saying it will create the power of the element, right? If you pass on 3, then you will see, so in each column it will give us the power of these numbers, right? 1 2 3 4. So it is creating 3, means it is creating 3 columns, and these are the rows, total rows. So how it is working? Okay, if you make it 4, the matrix is changed now into the 4 columns. 5, right? You see, into 5. We want to see its documentation, so you will get, this is the vendor generate a vendor mounted matrix, right? Columns of the output matrix are powers of the input vectors, right? As I said, this will create the power of input vectors, right? So these are our input vectors, and we are creating the power into the column, right? In each columns it is showing us. Okay, and order of the power is determined by the increasing. Okay, by default it is false. If I make increasing equals to false, then let's see what it returns. So if we make it true, by default it is false. Let's make it true. Then, so you see, it changes the way of generating the powers of input vector, right? It is now starting from 1 and then 4, 16, 64, these elements. Okay, so this is the purpose of this argument. Okay, if you want to use linear space function also here, you can use it easily. Dot vendor. Okay, and then I'm saying np dot linear space. Here I'm saying I want to start with 1, I want to stop at 10, and then I'm saying number of samples. Okay, let me make it 3. If you print array 6, basis on that you will get the output. Okay, so here if you see, so I'm generating 3 samples, right? 3 samples here, and each 3 sample I have passed into the vendor, so you are getting the powers of the vector, right? You see 1 5, because linear space actually generates the interval itself, we do not have any control, right? So whatever elements values generated, so based on that we have created the matrix. Okay, these are all 2-dimensional arrays. Guys, in this video, we will be learning what is intrinsic numpy ndarray creation function in Python. What is ndarray? The ndarray creation function can create arrays with any dimension by specifying how many dimensions and length along that dimension in a tuple or list, right? We'll see first numpy.once. What is it? So this once function will create an array filled with 0 values. The default dt is float 64. Okay, if you want to use numpy, you have to first import it. Numpy, we are just taking a class of it, and we are going to create one array variable np dot 0. Okay, So this is a function. So what this function does, it function actually create a matrix that is 2 into 3 matrix. We are going to create and then we are going to print which type of array it will be, right? And then finally we'll be printing the outcome from this array. Run the program. Okay, so here we are passing the dimensions, right? Row and columns like this. And again, so you will see, so all elements into the array represented in 0. Okay, all are 0 by default. It's a float 64 type. Want to define the type, data type of the elements, right? So you will get the integer type of element here. Okay, so 0 means we are going to create all element with 0 value. Okay, in this vector. Fine, this is two-dimensional array and it is showing that is returning ND array again. So this is zero functions, zeros. Opposite of this function that is 1, we are going to use it now. Instead of 0, we can use ones and the same type of argument here. Okay, so you already know that what would be the outcome, right? It is returning an the array and instead of 0 we are getting now value as 1. Okay, if you want to make it 3 into 3 matrix, get 3 into 3 matrix. Okay, now let's see what is a random function. So random returns random floats in half open intervals, right? We have to use, let's say, r. Let me take any variable and np dot random dot default range. Okay, so this we have to generate, and if you print r dot random, okay, it will give you the random number. So you see this random number, it's generated, right? It generates the random number between 0 to 1. Okay, if you want to get the type of this number, so you will get n. Okay, then this is n number, and if you want to get the type of this n, so you will see it would be a float type. Okay, so you will see it is a float type number. If you want to generate number in 1D one dimensional array, so you can generate in a different way. Print r dot random and we can say 3 comma. Okay, so what it will generate, it will generate a array, right? You see, if we want to create like 3 by 2 matrix, okay, then how it will create. So we have to say, let's say 3 by 2 matrix, and we have to this way. Okay, it will print 3 by 2. See, two dimensional array, all numbers would be between 0 to 1 range. Okay, let's see what is numpy dot indices. Okay, so numpy dot indices, what it does, it will create a set of arrays, one per dimension, with each representing variation in that dimension. Okay, if you have, and then you say np dot indices, here you have to pass on row and column 2 3. Okay, and then what it will give us, it will give us indices of row and columns only, right? Okay, so you see 2 and 3 indices, it gives you 0 1 0 1 0 1 1. Okay, if you have 3 into 3, then it will give you, right? If you look at documentation, so you will see dimensions. Okay, we have pass on, and then sequence of int t type we can pass on. There is a one option here, sparse. If you like to pass on sparse, so that means it will exclude your sparse array. To get the sparse array from the matrix, so you will see sparse array, it will take first and the second. Okay, right? If you make it false, then it will give the dense. Okay, so it will give the dense as you were getting previously. Let me make true. You want to get 0 and then 1 sparse. Okay, from your first array from the array and second array from the array. First it gives column, and then second it gives row, okay, as a sparse. Okay, this is what sparse means. Yeah, D type we have seen, can do it. Want to make it float, generated with float numbers, you see. Okay, all float numbers. So these are normal general ND array functions. Okay, guys, in this video we will be learning Python NumPy from records method. So what is from record method? We can create the record array by using the list of individual record. What does that mean? When you use from records, so this function actually returns you the different type of object, that is record array, and record array can be generated with help of list of individual record as we do in Python list. Okay, port alias numpy. So we wanted to use from record, right? So we will be using np.core.records.from records. This is the method, right? So you will see it is returning as the np.rec array, right? That is record array. Record array consisting of given rec list rows, right? Rows in terms of spreadsheet, right? Row and column. Okay. So we will be using this function. Okay. It will return something to us, that array1, and it will accept some parameters. Either you can pass on iterable, rack list, or you can define your list. Okay, that would be your list, and here we can pass on the item in tuple, right? So if I say tuple1, that is id, okay, that is name, and that is age, that is my tuple1. Okay, and I can take tuple2, and then I can use this tuple here. Okay, t1, t2. Okay, so you'll be getting my code array. If you check the type of this array which is returning, you can easily check the help of type. Okay, let me run the program. So you are getting your two record array, right, in form of tuple one and second, right? Or you have a different way. Either you can do this way, or you can do this way. Control, and then either you can do this way. Okay, these are the same thing. Right, two. Okay, if you're in the program, you will get the same output. Okay, right? This is first thing. Okay, I have another parameter in this method which can be passed. Let's say names. So if you want to specify the name of the column, so you can say id, and then you can say name, and then age. So actually this will be converted into the rows and columns, and the columns name would be defining with names, right? Name argument. Okay, if I'm okay, so if I'm printing array2 dot id, right? So this id would be returning to me. Okay, you see the id column is returning to me 1 and then 2. Okay, if you print the name and then age, right, so you will get the all three things, right? All three columns you will get in form of array. Okay, right? If you want to check the type of this thing, what is this type of property, so you will get to know this is a type of ND array. Got it? Because we are getting all elements in form of ND array, right? Through one column, right? I have another way to create record array object. Array1 I am going to take, that would be 1 or 2, right? Array2, that would be right? Or you can even say np.arrays, right? Here you have defined one array and you can say dot array, right? So a1 and a2 we can define in this form. If you say a1 or you say a2, right? Get record 3, so you will get record 3, record 3, the output, that is rec array, and then you are getting the output. If you want to print individual array from this rec array 3 or 1 or 2, so you can point it out like this. Okay, 0 1 2, you can pass on the indexing also, so you will get 1 3. Similarly, if you pass on 1, so it will give you the second record item. Okay, 2 4. Okay, so this is how it works. In the same way, if you see here and then say 0, so you will get the first record array. Okay, you are getting, this is the record. Okay, this is the first record you are getting like this. You want to get the product of the same array which you have passed like this, so you can multiply like 2, so array 3 print, you will see the differences, right? You see array 3, I have made the product, like I have multiplied these records with 2, so you will get 4 record array. Okay, you can do what you want, right? Instead of 2 array, you just passing and you multiply the single array in the multiple products, right? The same product will be creating. Okay, you have other arguments in this method. You can use shape, you can use d type, formats, right? Name we have used, title you can try, aligned, byte order. So try these arguments yourself and see what advantage you get through these arguments. Okay guys, in this video we will be learning NumPy array indexing in. So we'll be covering these points in this tutorial, but before getting started with anything, you have to install NumPy on your computer. What is array indexing? Array indexing is the same as accessing an array element. You can access an array element by referring to its index number. So the indexes in NumPy arrays start with 0, okay, meaning that the first element has index 0 and the second has index 1. That way it goes. Okay, so first we have to create an array with help of NumPy library. We have to import it, and then we will be accessing all type of array, one dimensional, two dimensional, third dimensional. Will be accessing those array. Okay, let me import first NumPy. We are taking alias like np. If we creating array 1D, can define any element inside the array. Okay, so it will return you the ndarray object, right? Just see what type of array it is returning. Let's run the program. So you will see, so that is returning ndarray and we have this array list. Okay, if we want to access its any element, we can do it easily. Print array 1D. We can locate our element with index 0 1 2 3 and so on, right? If we want to get the element which is positioned at first, so you will get 2 is the output. Okay, because index always start with 0 0 1 2 3. Okay, right? If you want to see what is the dimension of this array, you can also get this one. Array d dot ndim is the attribute. It will give you which type of dimension. It is one dimensional array. Okay, so we have seen how we can access one dimensional array with index. Okay, if you type any other index which is not there in the array, so it will give you the error. Okay, because you did not find any indexed element, right? On 10th position, we do not have anything, so it raises error. Okay, keep in mind, you have to make sure whether which element you are locating, it should be there in the array. Okay, let's see how we can access two-dimensional array. Let me create one two-dimensional array quickly. Okay, so let me print all the things, the type of array, the array elements, and the array dimensions. Okay, I have changed the variable name. Let me run the program. You will see this is a two-dimensional array. It is type of ndarray and it is two-dimensional array, right? Okay, if you want to access any of the element of this two-dimensional array, you can easily do it the same way. Okay, so you can do from 0 row, we have to locate column 3. Okay, so you will get the output 0 3 is 4, right? It means this is the 0 index. Okay, and the location is 3 means 0 1 2 3, so that is 4 is outcome. Okay, you want to get a single element, so you can also get like this. Okay, so you are getting 5 6 7 8, 0 and 1 index. Okay, in this two-dimensional array. One more thing, in one-dimensional array, if you want to use arrange function, you can also do. Okay, instead of array, you can use 1d1. Instead of array, okay, you can say give me the element, full element till 10. Okay, and the type also you can print it. You will get full elements from this one. Okay, you are getting these elements 0 to 9, you are getting same way. So let me take 3. So 0 1 2 and 3, 3, right? You see the output is 3. Okay, if you want to change the shape of this array also, you can change it. How? You can change its shape. Let's say 2 and 5, you want to change its shape, then your output would be different, right? Okay, 3 is out of bound. Now let me make 1, so it will give you the output. You see it got created in 2 into 5 row. You see, this is one thing. Okay, you see 2 into 5 shape we have given to this array. Let me put a separator. Let me print it again. Okay, so you see, so this is a type which we printed here. Okay, we created first this and then we convert it into shape, then we got the array, and then we got the indexing of the second row, right? This is the second row, 0 and 1. Okay, the index is 0 and 1, and this is the element. Okay, okay, you can also do like 4. So what would be the output? Then you will get 9. Okay, because we are saying from first row. Okay, from first row. Okay, we have fourth element 0 1 2 3 and fourth, so 9 is the output. You can do this way also. Okay, now let's see access three-dimensional array. Let's create three-dimensional array. Control C, Control V. Okay, let's print it. Okay, so first you will print what is the output, what is the type, and what is the dimension of it, right? So let's run it. So we are getting this three-dimensional array is the output which we created, and this is a type of array which we are returning from here, and it's a three-dimension, right? If you want to access any of the element from three-dimensional array, so it is same as 2D array, right? So say, and then let me take 0 element and then second element. Okay, you run it, so you will get 3. Okay, 0 in the one dimensional, The second dimension also 0. Okay, and the final three dimensional we got 2, 0, 1, 2, 3. Okay, if you say this is the 1 and then you will print it, so it will get 7. Okay, because here we are saying 0. Okay, in the second one this is the first row, this one, and then second is the 0, 1, 2, the element. Okay, if you make it 3, so it will print 8. See, it will print 8, right? So this is how we access three-dimensional array. You can easily locate your element into the matrix. Okay, let's see what is negative indexing, right? As we have one-dimensional array here, if we want to get the element from the last, so we can use a negative value to access the element. If I say, right, -1, so you will get the different output, right? Here you will get different output. So you are saying 4. Okay, because I am saying from last position give me -1 element. So -1. Okay, let me take -2, so it will give you the different output, right? 3, -1, -2, -3, -4. Okay, you say -4, so you will get 1. So this is, see, this is 1. This is negative indexing. Okay, if you put -5, so it will give you the error, right? Because indexing is not there in the array, right? It is not correct. Okay, so this is negative indexing. You can use the same thing into two-dimensional array. If you want to locate, as you see here, okay, what is the output? The output is 4, right? So 1, this is the row. Okay, so this is the row we are printing here. Okay, if we want to navigate from this and we want to say -2, what would be the outcome? It would be 7. Okay, so let's copy, right? So here the output would be differ, right? You see, would be 7, right? You see -2 because 1, -1, -2. Element 0 and first element, okay? And then from first element we said -2 location. So that is 7, okay? Guys, in this video, we will be learning NumPy array slicing in Python. I am using editor PyCharm and Python version 3.12 is installed on my machine. So let's get started with the video. What is slicing? Slicing in Python means taking element from one given index to another given index. Okay, we pass slice instead of index. This is the notation of slicing, right? And we can also define slicing and step to repeat. Okay, so these are two standard. If we do not pass start, it's considered 0. Okay, that is first rule. Second, if we do not pass and, it's considered length of array. Okay, in that dimension. Rule number 3, if we do not pass step, it considered 1. Okay, all rules are clear. Okay, let's start with the video. Now I am going to import NumPy. I'm taking alias and p. Okay, so we'll see array slicing. We'll be defining first array. This is our simple array. If you want to see what type of object this np.array is returning, we can easily check it and we can then print it. Run the program. So this is our array and this is a type of anti array we are getting. Right. Now let's come to the part of slicing. How slicing works. If we want to locate a specific index, then we can use array 1 and then we can use maybe 2 colon 2 means that is start with 2 and go to fourth, right? This is our AND index. Okay, let's print it, right? You see 0, 1, 2, 3, 4. It means it will stop here. Okay, it will stop here and then it will print us 4, right? If we take 5, it will take 5 also, right? That is first thing. Okay. If you want to say, I want to start with a specific and I want to reach to the end, then what will be the outcome? Then I'm saying I want to start from 3 and I do not want to specify any end index. Okay, then it will take the length of the array, right? If you print it, so it will go to the sixth position, right? From third. 0, 1, 2, 3, it will take 4, 5 and 6. All it will take. If you change it to 2, it will take 3 also. Okay. If you want to do the opposite of this, I do not want to start anything, but I want to stop it at third index, right? So it will start from 0. Okay, 0, 0, 1, 2, 3. It will stop here and it will print 1, 2, 3, all 3, right? Guys, now let's see negative slicing. Negative index always work from the end. Okay, so we can do like, I want to start with, let's say, minus 4, 1, minus 1, 2, 3, 4. I want to start with minus 4 and I want to go to minus 2. Okay, so this would be the range. So it will print according, okay, 3 and 4. Is it clear? If I want to make 3, so it will take 4 only, right? So you see, it will take 4 only. So this is negative slicing, right? It always start from and. Okay, always remember. Now let's see what is step. Step value to determine the step of slicing, right? If you want to take more elements, right? So you will understand better. I want to take this slicing. Let's say I want to start from 1 and to stop at 8 and I want to get every second item in this range. Okay, so what you will get, so you will get 2 4 6 8. It started from 1 0 1, it started from 2, it took 2, then it took 4 because we said every second element, right? So it start here, then second element would be 4, then it would be 6 and it reaches to 8. 0 1 2 3 4 5 6 7 8. So it took 8, right? So 4 element we got. If we take step 3, so it will take each 3 element, right? 2, then 5 and then, so this is how step work. Now let's see 2D array slicing. If you want to take 2D array, let me take second array. Okay, let me print it. Array 2D will return type. So here we have two dimensional array ready. Okay, it's two-dimensional array. Okay, and we want to slice this 2D array. So how it will work? So I'm saying I want to start this 2D array from, let's say, 1, and then I want to take slicing now, let's say 1 2 3. Okay, it will 7 8 0 1 2 3 0 1 2 3. So it will take 7 and 8 only, right? You see, and it go to first row. This is the this is the row at 0 and this is row at first. Okay, so how it is working? If you want to put 0 here, so it will take 0 1, it will take 2 and 3. Okay, so in the program, so it will take 2 and 3, right? So this is how slicing works with two-dimensional array. Guys, in this video, we will be learning what is advanced indexing with Numpy array in Python. In the previous video, we have seen how we can access one-dimensional, two-dimensional, three-dimensional array by passing integer as an index, right? If you see, this is normal ND array, and we have locate one element passing this integer index into this array, and this was the output. Okay. This is a normal array indexing, but with advanced indexing, we will see how we can get the element from ndarray by passing ndarray as an index. Okay, we will cover these points: what is array as an index, what is integer indexing, and boolean indexing. What is array as an index? Indexing can be done in NumPy by using an array as an index. In case of slice, shallow copy of array is written, but in index array, a copy of original array is returned. In order to use NumPy library, we have to install it first. If it is not there on the machine, you have to type in command on the command prompt, that is pip install NumPy. After installing NumPy, we can import it easily. Import NumPy. Let's create simple ND array. np.arrange will be using this time. We'll be starting from, let's say, 10 to 2 step. Okay, it will start from 10, it will stop at 2. Okay, and then we will try to print. If you're in the program, so you will get 10 9 8 7 6 5 4 3. It will stop at 2, right? If we want to pass on array as an index to get element from array, another array, if you get the element from array 1, passing the ND array as an index, so you will say array will be using, and in array function we'll be passing some indexes 1 comma 3 comma 5. Okay, these are our indexes, okay, which we want to pass on with this array, and then we will get the element from array 1. If you're in the program again, so you will get the item 975. So we are saying 1 3 and 5, 0 1 9 is there, 2 3 7, and then 5 4 5, the 5. Okay, so we can pass on array as an index to get element from ND array. We can also pass negative indexing with this array 4. So you will get -4 index also. -1, -2, -3, -4. So you will get 6, right? Now let's see what is integer indexing. Advanced indexing returns a copy of data rather than a view of it, right? Advanced indexing basically is of two type, integer and boolean, right? Integer and boolean. Okay. When integer are used for indexing, each element of first dimension is paired with the element of second dimension, right? If I have new array which is two-dimensional array, and if I want to get which dimension of array this is, and dim first, see, it is two-dimensional array. Okay, I want 0, and then I want 1, and then 2. This is for row, and this would be for columns. Okay, what are those? Let's say 0 0 and 1. If I print it, so you will get 136. Okay, let me print array 2 also. Okay, so this is my final array, two-dimensional array, and you are getting 136 means 0 row, and the column would be 0, right? So then this value is now coming first row, that is first row, 0 1, that is first row, and then item is 0, it means 3. In this column, the column is 0, we are getting 3. Then row number is 2, 0 1 2, the row number is 2, and we are getting column number 1, 0 and 1, we are getting 6. Okay, so this is how the array as an index works with ND array. Okay, here we have row, here we have column indexing. Okay, okay, let me take another example. Let me take another array, right? And then we will be reshaping this array, this 15 elements into the row and columns. Okay, array 3, and the type of array 3. Let's run the program. What will be the outcome? The outcome will be, it's a ND array, right? And it is 3 row 5 columns. You could see We have arranged 15 elements and 50 elements converted into the shape 3 into 5. Okay, so this is the output. Now we want to replicate the same thing. Let me take again np.array. Okay, this will return again ndarray passing. Then I am passing the column. Okay, again np.array. Now we are passing the columns indexes in form of ndarrays, right? So that would be 1, 0, and 2. Okay, array 3 is this. Okay, let's in the program. So you will see 1107, which means second row 0, 1, 2, first column 0, 1, that is the column. So 11 is printed, 0 row, 0 row, 0 column, 0 column. So 0 value is printed, 1 row, 0, 1, this row, and the column is 2. 0, 1, 2. So this is the column. So 7 is printed. Okay, it is clear now. This is a integer indexing if you say. Okay. Now let's see what is Boolean indexing. Is a part of advanced indexing. So the indexing has some Boolean expression as the index. Let's say we have some array 4. Okay. So this is the array. It's a one-dimensional array. If we want to filter out this array element on basis of some condition, an array 4, I'll be checking whether any element is greater than 10. Okay. So this is 540. And if we, let's say, take greater than 15, if we say, so you will get greater than 50 items. Okay, would be there. We want to apply any condition, array 4 percentile 2 equals to 0. Then you will get the output as per this condition. Okay, it will return true, false, and then it will give us the element, right? We can also get the power of the elements, which elements we are getting give us the power of these elements. So you are getting the power of this element. So this is how Boolean indexing works with ND arrays in Numpy. Okay. You can also apply this condition and get the another ND array with true or false value, right? How? If you want to take another array, array 5, and you want array 4 should be check whether it is 10, and then if we want to print array 5, it will give you the value in form of boolean true or false, right? So you are getting false, true, 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 true means the first element has not satisfies the condition, that's why it returned false, and an other rest element satisfied the condition which is greater than 10, it gives true, 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 right? That way it works. So these are advanced indexing concepts with NumPy array. Okay, we have seen what is array as an index, we can how we can use it, what is integer indexing, what is boolean indexing. Guys, in this video we will be learning NumPy data types in Python. We will be covering these points: NumPy data types, character representation, creating array with a defined data types, converting data types on existing array, as type function, on what is overflow errors, right? I'm using editor PyCharm. Python version 3.12 is installed on my computer. Okay, what is NumPy data types? So NumPy supports a much greater variety of numerical types than Python does, right? As you know, Python has common data types like str, int, boolean, complex, float. But in NumPy, we have different naming conventions of data types. We have numpy.byte, numpy.ubyte, numpy.short, numpy.ushort, numpy.intc, and so on. We have long list of NumPy data types. Okay, so we'll see our first point of agenda, NumPy data types care representation. Okay, the first step is to we have to import NumPy library, right? If we have not yet installed NumPy library, then we have to type in one command, pip install NumPy. Okay, so after installing NumPy, we have to import NumPy. NumPy has some extra data types and refer to data types with one character like I for integer, U for unsigned integer, B for boolean, F for float, C for complex float, M for time delta, M for data type, O for object, S for string, U for Unicode string, V for fixed chunk of memory. Okay, these are some character representation, and we can use these characters while creating our numpy array. If you want to know the type of the value you have defined with Python, so how you get I, so you will get to know which type of data it is, right? So it is int, right? But here with numpy library we have different way of getting data type in numpy. If you have numpy array with you and you want to get what is the type of the data you have passed on with the array, so np.array. Numpy has a property of dtype so that we could get the name of the data type. This is the property you can use to get the name of the data types with the array, right? If you see, it's a int 32, right? Okay. But here in Python we have int. So NumPy has a different naming conventions with the data types. So these are integer values which you have passed on in the array function, and then you have got the name of the data type, that is int 32. Let's say if we pass string type of values array 2, if you run the program you will get different name, right? But with Python data types we have str. Okay, in NumPy for string we have less than u1. If we change the value, let's say ab and ba, then you will get the different name. It works like this. Okay, so this is very simple way of getting the name of the data type in NumPy. Okay, now, so as you know, we have used array function. So when we use the array function to create array, so this function can take an optional arguments d type, right? That allow us to define the expected data type of array element, right? So how we can create integer type of value with d type, right? I am going to define a type for these values as. So what upper s means, it's a string type. If we run the program again, output is this, and data type is s1, right? Okay, this is a different type of data type name. Okay, if you want to specify the size along with the character, you can also do that, right? For I, U, F, upper S and upper U, we can define size as well. How? Integer 4 byte, so it will create 4 byte integer elements, right? So it created. Now the output has got changed. Okay, this is integer 32, right? If we want to make it 2, so it will create 2, right? It converted to int 16, right? So as I said, I, U, F, S and U, we can mention the size also, right? There is a one case if we define some elements in characters, right? Numeric value, right? In the same array. So what would happen if we say d type I, it's for integer. If you run the program, so it will give you the error, right? Because this is a data type I, which means it's a integer type. Okay, so we cannot club characters, because what it is trying to do, it is trying to convert each element into the integer, right? That is why it raised the error, right? If we make it 3, then it will show you the output, it will show you the name of the data type, right? It is int 32. Okay, we want to make it 4, so it will 4, it will give you 4, or 8, right? So it will give you in 64, right? We can specify size also. Okay, now let's see converting data types on existing arrays, right? And what as type method function does, this function actually creates a copy of the array and allow you to specify the data type as a parameter, right? These are my float values, right? Let's try to print this type, and then what we will do, it's a float 64, right? And we are going to convert this type into different type. Okay, so how? So we are going to create new array, right? Array 4 as type function, and here we are going to specify the character for the type of the value that we are taking I for integer. And if you print the new array, print as a output, right? So we are printing the array, then we are printing the type of the array 4. Okay, that's in the program. So array 4 we have to print it. So you will see, so we have initially the float type of elements with the array, and then we converted these float elements to the integer with help of as type function, right? Now if I take int instead of character, so the output is same, right? Either you take like this or either you take like this. Okay, right? Okay, these are same thing. If you want to convert your integer value to the boolean, so you can do it, right? Let me take 1 as a boolean value so that we can convert it. Instead of I or int, we can take 6, and then I'm going to take bool, it will convert. And if you print 6 array, so it will show you the boolean values, right? If you see, we have now converted this object, array object. This is a type of array 6 that is converted to bool, and the value of these are true. Okay, 7, run it, so it will give you 2 true. Okay, if you want to define your data type in a different way, instead of like this, you can do even array 7 now, and instead of the type this, I can take int 64, right? So this can also be used, right? If you want to create your array object like np dot, if you want to use your int, this built-in function, and then you want to define your integer value, so it will give you the same thing, right? Array 8 and print array 8. So it will give you the same thing, right? If you want to get the data type of this, so it will show you it would be a integer 32, right? This is for integer 32. We have multiple numpy data types. If you type in like np dot, so you will see int we have seen, float we have seen, complex character array, right? Okay, now let's see what is overflow errors. The fixed size of NumPy numeric types may cause overflow errors, right? Overflow means you are getting a bigger value at runtime, so it may cause overflow errors, right? That would be requiring more memory. So in this case, we have to be very careful about defining the data types in NumPy, because it will not give you the overflow error, even it will give you the wrong value. Okay, let's say if I'm going to use a one power function, okay, so that is built in there, and I'm going to create a power of 100 with this specific number. The d type would be, let's say, np dot maybe integers int 64. So it will create the power, right, for this, because the size is sufficient for this one. If you run the program, so the size is sufficient, right? So it created the power of 100 with this number. Okay, let's say if we are going to define a less data type in terms of size, instead of int 64, we are specifying in 32. This is my different variable, and if we print it, so it will give you the different output. Okay, it will not give you the correct value. Okay, you see the value is not correct, because when it generates the power of this number with this, so actually it did not get sufficient memory. Okay, so it gives us the wrong value, right? So we have to be very careful. We have to be very specific with the data types. Okay, so this type of scenarios always comes under overflows. Even if you are going beyond int 64 also, okay, so it will not give you the exact value. It will not give you the correct value. It will give you the wrong value. You see, it gave you 0. Guys, in this video, we will be learning what is NumPy array copy versus view, or copy and view in NumPy array. We will be covering these points: how to check no copy, what is view or shallow copy, what is copy or deep copy, And finally, we will be checking if ndarray is a view or a copy, right? Okay, I'm using editor PyCharm and Python version 3.12 is installed on my computer. Now we'll see what is copy and view, right? So while working with NumPy, you might have seen some functions written copy, whereas some function written the view. So main difference between copy and view is that the copy is the new array, okay, whereas the view is the view of original array. In other words, you can say the copy is physically stored at another location and view has the same memory location as the original array. Okay, this is very common Python interview question. What is the difference between copy and view function? Okay, so now let's see what is check no copy, whether is there any copy of ND array or not. Okay, so normal assignment do not make the copy of array object, right? Normal assignment means if we are assigning some object to the another, right? So it doesn't mean we are copying the array object, right? Instead, it uses the same ID of the object. First, we import NumPy library. Okay, we are creating very simple array. NumPy array function. It is one dimensional array. We'll be assigning this object to another, right? Reserve one, and then we will be printing okay their IDs. ID of array one, and we'll be using ID function. As I said, it is expecting one argument, that is object array one, and let's run the program and see what is the ID of these objects. So ID of these objects is same, okay, no change. Okay, if we change the element of array 1, right, that is the 1 position, I'm going to change to 30. Okay, and then we'll be printing the ID again and we'll printing the original array. Okay, so that is my original array and print. Okay, so if you see the 30, it's changed original array. Also, it's changed to the reserve one. Okay. And if you notice, the ID is same, no change. It means there is no copy of anything. Okay. There is no copy of any object. We are referencing to the same object in the memory. Okay. This is one thing. Now let's see what is view or shallow copy. Okay. Let me remove this. Okay. Run it. Okay. Just to make the output clear. So the view is just a view of the original array and view does not own the data. When we make change to the view, it affects the original array, and when changes are made to the original array, it affects the view, right? Vice versa. Okay, how? I'm going to make a view of array 1 with help of view function, so you will get the idea, right? Same thing we'll be doing array 1 with help of id function. So let's print it. If you print, so you will get the id of array is different and the id of view is different. Let me change something to the original array. Okay, 80, right? And then we will try to print the original array. If I say array 1, then view 1, instead of id, we are printing the actual array object. Okay, so let's print it. If you notice, so the 80 has been set to both the object, right? Array 1 and even v1. Okay, which is proving that it has the same memory address. One more case we can prove here. If we make v1, let me take 0 position to 70, and then we will print the array again. Let's see what would happen. So you see 70 has been set to both object. Okay, we have changed the original array also, we have changed the view array also, which means it is pointing to the same array object. Okay, let's see what is copy or deep copy, right? Here advanced indexing always creates copies, right? Advanced indexing means, which we have seen, index as an array. Okay, you remember in the last video we have seen index as an array. Okay, so advanced indexing always creates copies. Let me remove this code. The copy is completely a new array and copy owns the data, right? Which means it has the different memory address. Okay, owning the data. When we make changes to the copy, it does not affect the original array. Okay, it is opposite of the view or shallow copy. Okay, so let's prove it. Instead of view, we'll be using one function, that is copy. Okay, and we'll be defining c1 copy 1. and C1. Let me run the program. Okay. If you see, so the ID of the array 1 is this and the ID of copy 1 is different. Okay. If I change anything to the original array, printing the ID again, and we'll printing the original array. Okay. Instead of ID, let me run the program again. So you see 40 has been set to only array 1, right? Because we have changed the array 1 only. Okay. It does not affect the C1, the copy. Okay. The C1 is this, right? And even the ID of both object is still same as it was previous. Okay. So this proves like if we are making any changes to the original array, it only affects the original array. It does not affect the copy array. Okay. If let me do the vice versa, or let me make it C1. Okay. 40 to 50, I'm going to assign it, and then we do it again. Okay. So you see it's changed to the copied array, right? It does not affect the original array. Now let's check if ndarray is a view or a copy, right? So to check whether array owns its data in view and copy, so we have one property, right? We have one attribute base that returns none if the array owns the data, okay? Else the base attribute refers to the original object. Okay, so we have already created a copy, and here what we can do, just remove this line, and we don't need these even IDs, and we don't need this also, and we'll be creating another variable that is creating a view. Okay, if we try to call it c1 base and even v1 dot base, so let's see what it will return. It will return none in case of copy, right? Guys, in this video, we will be learning what is NumPy array shape in Python. We will be covering what is shape attribute, what is nDmin argument, okay? What is shape of an array? The shape of an array is the number of elements in each dimensions. For example, we have one dimension, we have two dimension, three dimension, four dimension, and nth dimension. First, we have to import NumPy, np, that is the alias. If we want to create NumPy array, so array function we have to use, and we are going to create two-dimensional array. You want to print it, when you will get the type of this object, right? Let me run the program, you will get the output. This is the array which we created, and this is a nd array type. Okay, let me move this window to the right top. If you want to get the dimension of this array, you can easily check it with one attribute array1 dot and dim. You will get the dimension of this array, that is two-dimensional array, okay, which we created. Now you want to check the shape of this array. You have to use one shape attribute, the object, and you will get what is the shape. The shape would 2 and 4. This is row and this is column, right? It is 2 into 4 shape, okay? 2 rows and 4 columns. Guys, in this video, we will be learning what is NumPy array reshape in Python. We will be covering these point reshape 1D to 2-dimensional, reshape 1-dimensional to 3-dimensional, unknown dimensions, and finally flattening the arrays if you have 2-dimensional or 3-dimensional array. I am using editor PyCharm and Python version 3.12 is installed on my machine. First, we see what is shape. The shape of an array is the number of elements in each dimension. This is shape. Reshaping means changing the shape of an array. Okay, with reshaping we can add or remove dimension or change number of elements in each dimension. Okay, before getting started with the program, you have to make sure whether NumPy library is installed on your computer. If it is not yet installed, you have to type one command on command prompt, that is pip install NumPy. Okay, you can install NumPy through your terminal also. This is PyCharm terminal. Let me import one library, that is NumPy. We are going to create one array. Okay, that would be using NumPy array function. Okay, if we print the array, printing like this 1 to 12, right? This is one dimensional array. If you want to reshape this array, then you can use a reshape function on the ndarray object 6 by 2. Okay, and you can take another array and then you can print how it works. Let me run the program and you will see a two-dimensional array is created here. There are 6 rows and 2 columns. Okay, this is two-dimensional array. If you want to know what is the dimension of the array, and dim property you can use, run the program, you will see this is two-dimensional array, right? Okay, so this is reshaping one dimension to two dimensional. Okay, this is one dimensional array and we have reshaped this array 1 to the two dimensional, right, with the help of reshape function. Okay, if you want to reshape this one dimension array 1 to three dimensions, so what you have to do, you have to take another variable, then we have to break this array 1 into shape 2 comma 3 comma 2, right? Which means the outermost dimension will have two arrays, right? Okay, that contains three arrays, each with two elements, right? Okay, so if you print dimension of this array, so right, whether it is converted into the three dimensions or not, right? Run the program and you will see. So array 1 is reshaped into the three dimensions, right? This is three dimensions, you see, and we have two elements. As I said, we have two elements, one element, this is one element, this is second element, right? And each element has 3 rows 2 columns. Okay, 3 rows 2 columns. Okay, three dimension of this array 3, right? What is unknown dimensions? You are allowed to have one unknown dimension, right? So which means you do not have to specify an exact number for one of the dimensions in the reshape method, right? Okay, here. So you can pass -1 and Numpy will calculate the numbers for you. So how it works then, if you say I'm going to take this statement for array 4, okay, and then we are going to reshape this 12 elements, right? Okay, this array 1 we are going to reshape and we are passing the unknown dimension, right, with -1. Okay, so let's see what would be the output. Array 4. Okay, so if you see, this is 6 into 2. We have three-dimensional array. Okay, let me try to print the dimension through this property or attribute, right? So we will see this is three-dimensional array. Okay, and if you want to get the shape also, okay, so you will get to know. So what is the shape? So the shape is 6 to 1, right? If you want to say 3 into 4, okay, then you will get 3 into 4, right? Let's see what is flattening the array. Okay, let me take another array which would be two-dimensional array, and okay, it's fine, it's two-dimensional array. And if you want to flattening these all elements into the one-dimensional array, so you can use -1 in the reshape function. How? So you are going to take array 6 for this, and then we have to make array 5 and reshape, and then -1 has to be passed on as an argument, right? And then we have to print it. Array 6 has to be print. Run the program. So you will see all elements are flattened into one dimensional array, right? This is two-dimensional array. If you want to check whether it is two-dimensional or not, so array 5 dot and dim can check. Okay, and you will see it's a two-dimensional array, right here in this line. And then finally we have flattened array, right, a one-dimensional array. Okay, if you want to see whether which dimension of this array 6 is, then you can also check, right? It became one dimensional array. Okay, we can flatten any dimensional array into the one dimensional array anytime, right? With help of reshape function and passing -1 as a value. Okay. Guys, in this video, we will be learning what is NumPy array iterating in Python. So I have some code handy to save time. This is the NumPy library which I have imported. This is the alias, and these are some NumPy array declaration, one dimensional, two dimensional, and three dimensional, right? So first, what is iteration means? The iterating means going through elements one by one. Okay, as you know, as you do in C, as you do in Java. Okay, this is very simple way to iterate array, right? We'll be using for loop. We can iterate any type of array, whether it is one dimensional array, two dimensional, three dimensional, or multi-dimensional array with help of multiple loops. Okay, so in order to use iteration with 1D, you have to apply for, right? That is one dimensional. Within the program, you will get the output 1, 2, 3, right? Similar way for two dimensional array, right? We'll be printing J. This is two dimensional array iteration. If you run the program, so you will see all your item are flattened 1, 2, 6, right? 1, 2, 6 are flattened. Okay, let me take the separator, the program again. Okay, story 1, 2, 3, 4, 5, 6, right? Similar way for 3D, ij, another loop we have to apply. This is the same as we do in C, C++ or Java, right? In the data structure, right? Here J will be taking K, right? We'll be printing K, right? So this is our three-dimensional array. Okay, let's in the program. So you will get 3D 1 to 12, right? 1 to 12. These items. All items are flattened, right? With the help of this loop. Okay, right? So this is very simple way to iterate your arrays. But with NumPy, we have some functions, built-in functions. We can easily flatten this type of arrays, right? Three dimensional, four dimensional, five dimension. We can easily do that, right? We have to only just pass on the array in those functions. Okay, so first we'll be seeing this ND enumerate function. Okay, how it works. Let me remove the code. Okay, now we have to use this function. We have item, any variable name you can take, and then one function from NumPy library, that is ND enumerate, and then we have to pass on our array. One dimensional will pass, and then you can print easily your item and index, right? Okay, if you're in the program, so you will see your items, your elements are printed 1, 2, 3, right? And what is this? This is the index, right? This I is the index. On which index this element is, right? This function gives us extra advantage, like you can get the index also with this function. Okay, if you want to iterate your two-dimensional array, you can do the same way, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If you observe here, so as an index, we have row and the column, right? 0 row, 0 column, that is 1. 0 row, 1 column, that is 2. 0 row, second column, that is 3. Okay, so on it goes, right? If you make it 3D, then it will show you like this, right? You see? Now let's see what is nditr function. This is very important function. It has so many arguments, right? It's a very helping function that can be used from very basic to very advanced, right? So it is same, right? As we are using nd enumerate function. So we'll be taking item, right? And nditer, okay? And then this is my two-dimensional array, and then 1, 2, 3, 4, 5, 6, right? All your element in the two-dimensional array is flattened, right? 1, 2, 3, 4, 5, 6. You can easily iterate one by one. You are iterating here in this loop. Okay, we have other arguments in this function. Okay, if you want to iterate your three-dimensional array, you can make it easily, right? In the program, so your three-dimensional array is printed, right? 1 to 12, right? The element is started from 1 to 12, right? This is in three dimensions. Okay, you can put any condition, you can apply any logic here. Okay, you can check anything in the loop. Okay, we have one parameter with this ndtr, that is the operation data types. Okay, we can pass on the operation data type also. Currently it is integer type. Okay, if you want to make it a string type element, while iterating it, so it will convert directly from integer to the string, right? As represent string. Okay, we have changed the type of the element, right, in this method. Okay, so we'll get the string type of element in the output, right? If I run it, okay, so iterator operand requires scoping a buffering. Let me make it I, then let's see, print. Yeah, it is printing. Okay, for s it will of course will take one more argument, that is buffered, right? Yeah, it's a flag. We'll take one more argument. If you say, that would be buffered. Okay, so this is another type flag, right? We are flagging, so then you will be able to print your string type element, you see. Okay, so these all types are converted to the string, right, from integer. These are integer type of elements and got converted into the string type. You see, b, a single quote is there, okay, with the element, right? Means it is a string type. Slicing can also be used. As you know, we call it basic indexing, right? So let me copy this function, and then I'm going to pass on slicing, right? If I say this row from 0 to last, and the column would be 3, right? You can try yourself, right? Any slicing technique you can put here, okay? So you will see the output is 1 and 4, right? If you put 2, you will get 1, 3, 4, 6, okay? Right? If you make 1 to 2, right, you will get 2 and 5, right? Now let's see iteration order. In nditr function we can pass on the order also. Okay, if you have another loop, and we will be using order, right? Instead of this, we can say order. We'll be putting order either C or F. It's a C style, F is for Tani style, and you will get your order would be for 3 dimensions. You will get, let me put a separator even, print, and then the program again, right? So you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, right? 0 to 12. If you put F, so you will get different type of ordering, right? 1, 7, 4, 10, 2, like this. Okay, the order has been changed while iterating the array. Okay, it took 1, 7, 4, right? 1, then 7, and then 4. Okay, 1, 7, 4. Okay, so it changes the iteration. If you make it 2D with 2 dimensional array, so you get 1, 4, 2. Okay, so orders gets changed every time, right? You make it, see, so it will goes by default, right? 0 to increasing order, it will take increasing order, right? Now let's see modifying array value, right, with the help of nditr, right? So there is one more arguments we can pass on, that is operation flags, right? And if you remove this one, copy flags, you can pass on, and then you can put read write, right? In order to modify it, so you have to say item, and then you have to use 3 dot, right? And then you can put anything, right? If you want to plus any value with your item, current item, so it will add, okay, that value in the program. So you will see, okay, so 10 is added into each item, right? 11, 12, 13, 14, right? It is 2 dimensional array. 1, 2, 6 it goes. Each element is being added with 10, right? If you want to multiply it, you can do it. Okay. It means it is modifying your actual element with the help of itr function, right? While iterating, you can modify even your actual element. 10 to 16 output is. Okay. Let's see what is external loop, right? How external loop parameter works with nditr. Okay. Flags, right? This time we have to use flags, and we have to make external loop. So it will give you the external loop of the array. Let me remove it. This is 2 dimensional array, and then let me run the program. So this is your first element of the loop. Okay. 10 to 60, right? Because it, okay, because it got converted now. This is modified first, and then we extract it. If we take 3 dimensional here, and then run the program, so you will get Okay, 1 3 4 5 6 7 8 9 12 side, it will give you the external loop. Okay, and then you can even do a for loop. Okay, you print I, so it will give you the flattened array, right? You see, it will give you the flattened array, right? Did you understand the external loop parameter, right? So if you see how many time it ran, so you will see print, let's say a, so then you will see how many time it ran the upper loop, right? It ran only once, right? Which means the external loop has been created, right, with this command, with this parameter, and that external loop converted to the one dimensional array, and then one dimensional array we have iterated like this. Okay, now let's see what is broadcasting iteration. So which means if we have two arrays, these are broadcastable. Okay, and a combined ND-ITR object is able to iterate upon them concurrently, right? Concurrently. Okay, let's say I have two array 1 then array 2 will be using the broadcasting technique. Okay, so how? For, let me take x and y as a variable to point array 1 and array 2 object, right? And let's say np dot ND-ITR, and then we can pass on our array 1 and array 2. Okay, got it? And then you can combine print x and y, right? So it will iterate concurrently, right? Both object. So this is called a broadcasting technique, right? So 1, 10, 2, 20, 3, 30 like this. Okay, this way you can apply your formatting. Okay, if you're in the program, so you will get like this. Okay, 1, 2, 3, 4, 5, 6. Okay. Guys, in this video, we will be learning joining NumPy array in Python. I'm using editor PyCharm and Python version 3.12 is installed on my computer. These all functions are used to join multiple arrays, right? Now let's get started with our tutorial. What is joining in a NumPy array? Joining means putting contents of two or more arrays in a single array. Okay. NumPy provides us various functions as you can see here, which help us joining the arrays. Okay. Now let's see what is concatenate function. We pass a sequence of array that we want to join to the concatenate function along with the axis, right? If axis is not explicitly passed, it is taken as 0, right? First, we will try to join two arrays with help of concatenate function, and we will see axis parameter. We have to import NumPy library. We'll be creating two NumPy arrays to join. Then we'll be creating a result. np.concatenate function we'll be using. It accepts the arrays, the tuple array. We have to pass on array 1 and then array 2. Okay, we'll be printing the type of this array. Let's in the program. You can see the type which is returned, that is ND array. As you can see, all elements are printed from left to right in a single dimensional array. If you want to join one more array, array 3, run the program again, you will get all your elements from three arrays, right? So this is how joining works with concatenate function. You can pass on n number of arrays. If you want to get the axis of your arrays, then you can pass on axis equals to 1 in this concatenate function. Let's see, we'll be creating new arrays which would be two-dimensional array, and we'll be try to use the same code but with a new argument, right? And axis we have to pass on as 1, right? If you're in the program again, so you will get your axis also with the array, right? 1 2 5 6, right? So these elements are taken as a 0 column, that is one column. This is a single row, right? So that is how axis works. If you make it 0, by default its value is 0, then your whole array would be flattened. You see, in a single row you could see all your elements. Okay, now let's see what stack function means. We can concatenate two one-dimensional array along the second axis, which would result in putting them one over the other, right? That is stacking, right? So it will work with basic principle of stacking. Okay, so let me take array 1 and array 2. Okay, then we'll be taking result 4 this time, np dot stack function, right? Array 1 will be passing array 2. Okay, and we will be using axis equals to 1. Okay, print result 4. If you're in the program again, so you will get your all element 1 2 3 4 5 6 2 7 8. That would be in the stack form, right? 1 5 2 6 3 7 4 8, right? Because axis is 1. You see 1 5 2 6 3 7 4 8, right? It took this stack 1 5 2 6 3 7 4 8. 1 5 2 6 3 7 4 8. This is two-dimensional array, right? If you make it 0, then your stack would be something 1 2 3 4 5 6 7 8, right? It is a default pattern. Okay, so this is how stack works. Now let's see what is hstack function. So NumPy provides a helper function hstack to stack along row, right? To stack along rows. Okay, so if you use array 1 or array 2 with hstack, so you will see the difference. Now result 5 and then hstack, and we'll be using these array 1 and array 2 same, right? Result 5 will be using, let's in the program. So you will see all your elements are stacked along rows, right? If you see the documentation, so you will see stack arrays in sequence horizontally, right? This is column wise. Okay, so this is how it is working. If you want to use vstack, so vstack is opposite, so it will stack your all arrays along columns, right? How it works, let me take another result 6 and then 6, and we'll be using vstack. Okay, let's in the program. So you will see, so your both arrays are into vertical, right? In hstack it was horizontal, but now vstack is vertical. So we take array 3 also here, array 3, and then run it. So you will see, so your all nd arrays are taken as vertical, okay, in the stack. Okay, whereas h stack would be growing from left to right, right? Array 3, if we pass here, if you're in the program, so you will see your stack is getting increased from left to right, right? You see 1 to 4, 5 to 8, 9 to 12, right? All elements are in single dimensional array from left to right. So this is the difference between h stack and v stack. Okay, we have another method that is dstack. So NumPy provides a helper function dstack to stack along height, right? Which is the same as depth. It means it will take your all arrays in depths, right? If you take another new variable 7, and then you will use dstack and array 1 2. Okay, array 7, run the program. So you will see it took the depth itself, right? We don't know, right? It decide itself, right? It is three-dimensional. If you want to see which dimension of it is and dim, you can use to get the dimension of this array. So you will get it's a three-dimension array. Okay, right? If you see the documentation, it says stack arrays in sequence depth wise along third axis. Okay, it is a third axis. So we have seen joining NumPy arrays. We have seen concatenate function, stack, hstack, vstack, dstack. Okay, guys, in this video we will be learning how we can split a NumPy array. We will be using array underscore split function. Before that, we have to understand what split function is in Python, right? If we split normal string into Python, so how we do? I have taken variable that is coding news today. If you want to split it, you will be using dot split on str and then printing the return list. Okay, this split function will split this entire string into multiple parts in form of list. So this is first element, this is second element, and this is third element into this list, right? In the same way, array split function works. Okay, let's see how we can use array split function with numpy array. Import numpy. What is array splitting, right? Splitting is reverse operation of joining, right? We have seen joining operation in the previous video. Okay, so it is just opposite of joining. So let's use array split function. We have to create one array, and then we have to take result one array underscore split, right? If you see, it is asking for array which has to be provided, right? That is our array one, and then we'll printing press one as a output. Okay, and then we will print the type, what type of object it is returning. Array split function, run the program. Okay, we have missed the length, so we are saying we want to split this array into two indices, right? If you run the program again, so you will get two indices are created, right? One is this and second one is this, right? This array object into two pieces, right? One and two. Okay, if you want to make it three, so it will take three, you see, one, two, and three. The benefit of array underscore split function is it actually adjusts the element itself, right? You see, okay, so this is how split function works. If you want to point out your specific indices, you can easily do that, right? You can do 0, 1 and 2, right? 1 and 2. Okay, so each array element would be printed in this form, right? 1 2 3 4, right? If you make it 3, it will raise error because this indices is not there with this result. Okay, you see, right? If you want to check the type of this particular element, you can easily get it. Type, and then you will notice this is a type of ndarray, right? So each element which is splitted is type of ndarray. You can see here. Okay, and what is the type of this res1 object? This is a type of list, right? Which is returning all elements into the one dimensional, right? You can see this is a list object, it is returning. If you see the documentation of this function, you will get array, so which we have already passed, right, into a split function. Then indices or sections, you have to pass on how many pieces you want to split your array. So we have already used it, 3. Okay, and then the last parameter is axis, right? So as axis parameter, we will see, okay, how it will work. So we have to see two-dimensional array, right? How we can split it? Or we have to create one more array, right? That is two-dimensional array. So these elements, 6 elements we have taken into two-dimensional array, right? And if you want to split this array, so it is the same way. Okay, so you have to take res2 split, and then you have to pass your array two dimension, that is 3, and then you print your result 2, right? If you're in the program, so your two-dimensional arrays is now splitted, right? This is into three pieces. Okay, this is the list which is returning. Okay, in the list, that is your first element. Okay, this is your second, and this is your third, right? This is our two-dimensional array we have split it, right? If you make it 2, so you will get different output. Okay, so you will get that is 1 and that is second. Okay, so this is array split function, how it works with two-dimension array. Okay, you can change it 4, so it will break into pieces, right? 4 pieces. Okay, so let's see what is access parameter of this function. Okay, so access parameter means you can specify which axis you want to do the split around, right? Which means if you pass axis equals to 1 in this method, okay, let me make it 3 or maybe 4, and you want to specify axis equals to 1, If you see the axis, that is your first list. It has only into 4 pieces. So you have first array, right? This one from here you have, right? That is first, and that is your second array. Okay, 1 3 5 7 9, right? 1 3 5 7 9 11, right? This is first piece, right, of this. Okay, and 2 4 6 8 10 and 12, right? 2 4 6 10 and 12, this is our different element. Okay, this is, these elements are in different ND array. Okay, and if you observe, we have taken 4. So as per the elements, it created first 2, right? And then rest 2 are blank. If you see, this is third, right? And this is fourth. So this is the beauty of this function. If we do not have any array to adjust, right? So it will always create your array with blank values, right? You see, okay? If you make it 2, so those two arrays, blank array will go away, right? If you run this, so you see, this is how it works. If you make it 0, by default x is equals to 0. So you will get your axis 0 means like 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6, right? This is one piece. And the second piece is, you see, so this is how axis parameter works. Okay. These are two pieces. If you make it 3, then your 3 array would be located onto one position, right? If you see, we have split it into 3, right? So as per this, that is 1, right? That is 2, and that is 3, right? We have one more method, that is h split method. So h split method, uh, it is for splitting 2D array into 3 2D arrays along rows, right? So it works same as split with axis 1, right? If you use, let me make it 2, right? So it will give you the same result, right? Same result here. Okay, let me take result 3 and result 3, and instead of array split, I'll be using h split, right? And we have to say only 2. Okay, now run the program. So you will get the same output, right? You see, this is same output as you are getting with array split with the help of axis equals to 1 parameter. Okay, either you use h split function separately, or you use array split with help of axis equals to 1. Okay, this is the same thing. So we have seen array split function. So we have split one dimensional array, right? We have seen two dimensional array. Indices we have seen, axis parameter we have seen, and we have seen h split function, right? Guys, in this video, we will be learning NumPy searching array in Python. We will see what is NumPy.where function. You can search an array for a certain value and return the indexes that get a match. In order to use NumPy.where function, before we have to install NumPy library. To install NumPy library, we have to type in one command, pip install NumPy, either on command prompt, or you can type this command on PyCharm terminal windows. Okay, NumPy library is installed on your computer. You can import NumPy. Here we have to search an element in NumPy array. So NumPy.where function, which returns us the indexes or indices which are matched with certain condition. For example, I'm going to create a simple NumPy array. Here we will be defining some elements. Then we have to take result new variable name. We have to use np.where function, you could see. And then here we have to pass condition. If you see the condition, that is iterable, array 1 should match this condition. That will return us the numpy array. Again, we wanted to get the type of this array. and then we will be printing the output from this array. Okay, let's in the program. So you are getting, this is a tuple type result which we are getting in form of this. The array indices which we return, that is 3 and 5. The 4 is located on third indices and the fifth. Okay, 0, 1, 2, 3 we have, and 4 and 5. Okay, so we got two indices from this numpy array. If your element is not there in any of the array, you will get indices object as a blank. Okay, so here we can easily find our elements on basis of certain condition. I have added one more new element, so you will get one more indices, that is 1, 4, 6, 0, 1, 2, 3, 4, and then 5 and 6. Okay, if you want to satisfy any other condition with help of where function, for example, if you want to get the even number elements indices, so you can easily set your condition if you're in the program, so you will get only those elements, that is 0, 1, then 2, then 4, then 6, and then 7. Okay, let's see how numpy.search sorted function works. This method performs a binary search in the array and returns the index where the specified value would be inserted to maintain the search order. Okay, let's say we have another array, new array we will be taking, and you have to take one more variable, search sorted function, and then you have to pass on your array 2 where you are going to apply the filter, and then you want to get the indices of 7, right, where 7 is located. Okay, then we will be printing result 1, and even we will be getting the type of this object, right? If you're in the program, so you will get 1, right? 1 means 7 is located on the first position, 0 and 1. Okay, if you get 7 here, so then you will get different indices, that would be 0. Okay, if you put any element like 9 and you have taken the greater value from 7 here as a first index, as a first value, and then maybe more than that, okay, and you are getting more lower values because it works on binary search. So I have taken lower values than 7, so your indexes will be changed now. If you take, it would be 2 because it would be 0, 1 and 2. 7 will come after 6. So this is the sorting. First it is checking and then it is getting the next indices. Okay, so this is how it works. If you are going to take one more lower element before it, so you will get one more increment in this indices which is returning. If you're in the program again, so you will get 3. Now 7 will come on third position, 0, 1, 2 and 3. So we have one more argument in this method, that is side. Okay, if you see the side parameter which actually accepts the value as string, either left or right. Okay, if left, the index of the first suitable location found is given. If right, return the last such index if there is no suitable index, right? Okay, so let me make it more simple. Let me take the initials elements to understand easily. 8, 9. Okay, side you are taking as right, which means it will give you the index is 2. Okay, because it is checking from the right, 0, 1, 2. 7 is located at second position. Okay, if we make it left, so it will check from left, right? Where 7 is located, it is located at 1 position, right? 0 and 1. Okay? Rerun the program so your indexes would be changed to 2, right? Now 7 is located at 2, 0, 1, 2. Okay? If you want to check multiple values with search sorted function, you can easily use it. Let me remove it and I want to search multiple elements. Even 7 and 8 I wanted to search, right? I want to get the indices. So you will get 2 and 3, right? 0, 1, 2 and 3. Okay, if you make it 9 instead of 8, then you will get different indices. That is 4. 0, 1, 2, 3, 4. Okay, so this is how we can search multiple elements. Okay, guys, in this video, we will be learning NumPy sorting array in Python. We will see what is NumPy.sort function. We will be taking an example of one-dimensional array and two-dimensional array. We will also see what is access, order, and kind parameter with these functions. What is sorting? Sorting means putting element in an ordered sequence, right? Ordered sequence is an any sequence that has an order corresponding to element like numeric or alphabetical, ascending or descending. We have to create a array quickly. So we will be using np.sort function, that is direct function of NumPy library, and here what it is expecting a array, right? Array 2. Let me show you the documentation. It is expecting iterable that we are going to pass. We have access, we have kind, we have order, right? Print the array. So you will get to know it would be a ndarray, okay? And it has sorted your array. You can see this array too. It has sorted 6, 12, 5, 6, right? Because your access is by default provided as -1, right? If you put your access -1, your output would still same 6, 12, 5, 6, right? If you make it 0, then it will take 6, 12 as a column, 5, 6, right? 5, 6, 6, 12, right? If you make it 1, it will take 6, 5, okay? It will take 6, 12 and 5, 6, okay? So you know how axes work, either 0, either 1, okay, or -1, right? By default is -1. We have one more value with access. If you provide the value as none, so it will flatten your multi-dimensional array into one-dimensional array. If you run the program, so you will see all your element into the one-dimensional array and order has been applied on this array, right? Because it is returning a different array. Okay, so order will work same as it was working with ndarray.sort function. So I have copied the previous code, which was array 3 and the order was this. Okay, instead of array 3.sort, we will be using np.sort, right? That is our numpy library dot sort. Okay, and it will return us different array. That would be 5, and we have to print our array 5 object. Let me run the program. We miss the array which we have to pass on here in sort function. As a order name we have passed on, so it applies the ordering on a name field on these type of values. If you put age, then your order would be changed. Still we have 50 and 60, so the data is correct for us. If I make it 70, then this record would be appear first here, right? If you're in the program, so you will get Z as a first because 60 is less than 70, right? And we have applied the order on age. So this is age and this is name. Okay. Now let's see what is kind parameter. You have to pass on the algorithm name which we'll be using in the backend. Quickshot, merge shot, heap shot or stable. Either of the value you can provide in kind quickshot. This will take quickshot algorithm in the backend to short this numpy array, right? It will not take any impact here in the output because the default value for numpy.short method is quickshot. Okay, you will not feel any difference here, but it depends. If you are shorting a large set of data, then it will impact in the backend, right? The documentation of sort functions. So you will see this kind parameter has quickshot, merge shot, heap shot, stable, right? This is optional parameter. By default, quickshot is there. Okay. The actual implementation will vary with the data type, right? Okay. Here, if you want to specify merge sort, then it will work same as previous algorithm name, right? There is no impact. Okay. But these algorithms are getting used in the backend while sorting your numpy array. Guys, in this video, we will be learning NumPy array filter in Python. How we can filter arrays if you want to get some element out of an existing array and creating a new array out of them is called filtering. Okay. So in NumPy, you filter an array using a Boolean index list, right? A Boolean index list is a list of Boolean corresponding to indices in the array, right? So let's see one example. We have to import NumPy library first. Import. Let's create a array quickly. You are then creating another Boolean index list. Let's say bu1. Anything you can. If you put any Boolean value either true or false here as an element, this is a Boolean index list. If you pass on this Boolean index list into array, then which means your array would be filtered, right? If you print, then you will get to know what is the output. You see 1 and 7 element you got, right? 1 and 7 because 0 you have provided true and at last you provided true. Okay, which means first and the last element you are trying to filter. Okay, if you add another element here, so 56 will be retrieved, right? So you have to add on one more index boolean variable, right? You see 56 is retrieved. Okay, so this is how it will work. So your boolean index list would be equal to your number of element in the array, right? So we have passed on this boolean index list as an indexer into this array and then it got filtered here. This is a one way of applying filter. I'm now going to show you another way to filter out the array. Uh, let's say I take any variable like filter, right? Maybe filter one. There's an variable name. I'm taking this as a blank list, right? So here what I want to apply one for loop in the array element, right? I in array one, right? I want to check if any of the element is greater than 6, those element would be filtered out with my array. Okay. So here I have to check first if I greater than 6. Okay. And then I'm now adding true or false as an boolean list, right? As a true. Okay. Else if it is less than, then it will add false in this filter. Okay. What we have done here, right? This is the same thing. We are checking now if the value is greater than 6, those element will be filtered out, right? So we have prepared our boolean index list, okay, as we have done here. So in this filter one, now the same thing we'll be applying. We'll be taking another result 2 variable and then we'll be filtering array 1 and we'll be passing our new filter. Perfect. Let's print the output. If you're in the program, so you will get the elements which are greater than 6, right? You got 7 and 56. You see, if you make it 4, you will get one more element, right? 6, 7, 56. So this is a second way to set the condition and create the boolean index list, right? If you want to get the even elements from the array, you can apply the same condition, right? Which get the even numbers, right? Right? So you will get only those elements which are even in this list. So 4, 6, 5, 6, right? 4, 6, 5, 6. These are the even number in this array. Okay? This way you can also check any type of condition. Okay? So there is another way you can set your filters. If you want to, let's say, create another filter 2, this is new variable for us, and we want to say array 1 if it is greater than 4 and then filter 2, right? This way you can also apply the filtering result 3, right? Okay, if you're in the program, so you will get the elements which are greater than 4, right? 6 7 5 6 6 7 5 6. Okay, right? If you want to say 10, so you can set any type of condition, right? 1 4 6 7, right? 1 4 6 7. Okay, your elements are less than 10, and the same thing you can do what you have done here, right? Array 1. Okay, you will get the same thing, right? 4 6 5 6, right? What we are getting in this output, result 2. In result 3 even we have the same output because we have checked the same condition for even number. Okay, right? So elements which are greater than 4. Okay, 6 7 5 6, right? So you have seen four type of filtering with numpy array. First, you can create your boolean index list, that way it will filter. Second, you can create another filter blank list and then create your boolean index list, okay, on the basis of the condition with for loop. Third one, we can directly check the condition in the same statement, right? Guys, in this video, we will be learning comparing NumPy arrays in Python. You know the basic rule of comparing two values, right? We have few operators by which we can compare two values, right? Similarly, with NumPy array, we have few functions that can be used to compare NumPy arrays. We have function like greater, less, not equal. Then we will be using these operators to compare two numpy array as we do in Python, simple Python code. Okay, what is comparing, right? As I said, we can compare two values, right, by using operators like greater than equal, less than equal, is not equal, equal, right? So let's see how we can implement, how we can compare numpy arrays. First, we have to import numpy. Once it is there, we will be creating two numpy array quickly. Any type of element you can take. We have taken it is a type of element here with this array. See what is the type of this object. So it would be a and the array. If you're in the program, so you will get your array printed on the console, right? It's a type of ND array, right? Now our objective is to compare both array 1 and array 2, right? We can do it easily with some function. We'll be first checking greater than, right? If array 1 is greater than to array 2, right? So it will actually compare each element, one by one, right? It will take array 1 first element, then array 2 first element, then it will apply the operator, right, in the backend of this greater function, right? So we'll be using numpy.greater, which will give us the value in form of boolean, right, either true or false. Okay, result 1, this is a numpy function, numpy.greater, you see it is there, and here we have to pass on two arrays, right, array 1 and array 2. Okay, just print. Let's in the program. This is very simple. It will compare each element, right? If you're in the program, so you will see the output as ND array, right? It's a list of boolean, right? And we have seen false, 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 false. Every value is false, right? It is checking each element one by one and returning the boolean value, true or false. So greater means we are checking whether array one element is greater than to array 2. Okay, so it is not greater than, condition is not satisfied, that's why each index is showing value as a false, right? If you change, let's say 22, the element of array 1, then the first element output would be true, right? Because condition will satisfy. If you run the program again, you will see it is true. Okay. All other elements of array 1 are lower than array 2. Let's say 1, 4. So this value would be true because condition will satisfy array 1, this element is greater than array 2, this element. Okay. If you run the program, so you will get this is true. Okay. Two values are true, so you can easily compare your array elements by using greater function. Okay. If you want to check the same thing with help of normal operator, right? Greater than operator, you can do this as well, right? Easily. This is also possible, right? It is very simple, right? The result would be same. Okay. You see, the result is same. Either you can do this way or you can use greater function from NumPy library. Similarly, we have less than. If you want to check whether your array 1 element is less than array 2 elements, so you can use it. Okay. So let me take, right, result 2, and instead of greater we'll be using less function. Okay, result 2. So it will check whether elements are less than or not, right? Array 1 and array 2 it will check, right? So you see the result of result 2 is this. Okay, here we have false, true, false, true, true, right? We have true in the first index, right? True means yes, array 1 element, you know, this 3 value is less than to array 2 element, right? 23, right? That's why it is set as true, and we have these values also true means 5 is less than 45, 6 is less than 16, right? So how this function works, same thing you can apply with help of less than operator as we have done here, right? If you put less than here, so you will get the same output. If you run the program again, so you will get the same output, right? False, true, true, right? We have the same output. Even let me make it here one. Okay, so output is same for both ways, right? We have equal operator similar to that, right? If you put equal, it will check equality, okay, in the both array, whether elements are equal or not, right? I'm using equal, and instead of less than, I'll be using equal like this. Okay, the result is same for both the ways, right? So you are checking equal. So here the output is false, false, false forever. None of the elements is equal from both the array, right? If I make it 23, so then your output would be changed, right? In the second index, you would get true. Okay, if you're in the program, so you will get true, right? Only this place because both the array has the same value at the same index, 23 and 23. Okay, so this is how equal operator works and equal function work from NumPy, right? If I make the number of element distinct, right? Okay, so you will get the error, right? So operands could not be broadcast together, right? Shape would be same, right? So we cannot do if the number of elements are equal in both the arrays, then only it will be checking, right? Not equal. This is also the same, right? If you make it not equal, so you can use not equal like this as you do in Python, right? In the normal code to compare our arrays. If you see the output, you will get true, true means not equal. Yeah, this condition is true. 22 and 12 is not equal. This condition would be false because 23 is the same, right? In both the arrays on the same index. So this condition would be false here, right? So you have false, false. So what we have seen? We have seen NumPy comparison functions greater, less, equal, not equal. Along with we have seen normal operators how we can compare two NumPy array, right? Guys, in this video, we will be learning how we can get union of NumPy arrays in Python. We'll be using NumPy union 1D function. Then we will see what is a reduce function. What is union? Union means we can club more than one arrays into a single result set, which will be distinct for us, right? Here we are talking about how we can get the union of NumPy arrays. So first we will be importing a NumPy library. We will be creating two NumPy arrays. We will be printing both array. You will get the output 1, 2, 3, 4, 5, 5, 6, 2, 7, 3, 15, right? So these are different integer type of element. We have to take one result variable and then np dot that is union 1D function. This function will accept array1, array2, print the output. Let's print the type of this object also, right? What type of object it is returning? Let's run the program. So you will get 1, 2, 3, 4, 5, 6, 7, 15, right? So we are getting the distinct elements from both the arrays, and this has been clubbed into the one dimensional array. If you see the type of this object result1, that it is returning as ND array. Okay. If you want to get the union of result1 also with other array, you can do and then do the union of result1 with array3, right? So instead of array1, I'll be using result1 and then array3, right? If you're in the program, so you will get your extra element also with this result2. You see 30 and 50 elements is being added to the result2. Okay, because you have taken union of result1, that was the result of array1 and 2, and along with you have taken array3, right? So you have seen how to get the union of one dimensional array. Let's see how we can club different dimensions of array to get the union, right? Array3, we make it two dimensional, right? Okay, so this is two dimensional array. So we have ndim property to get the dimension of array. Array3 we have taken as a two dimensional array, and we have one dimensional array, right? Let me run the program. So you will see still we have the same output, right? There is one two dimensional array and others are one dimensional array, right? Or you can make it more simpler. You can take array4 and keep your element as singles, right? 2, 30 you can take, even 50 you can take, and more elements you can take like 67, 90. Okay, so these are our one dimensional array. Okay, in array4, instead of result1, we would be getting array, right? We're in the program. So you will get a distinct element from these two arrays, right? Okay, this is how it works. Let's see, we make it third dimensional array, right? Let's see, will work. We have to keep row and column equal. Shape should be equal, right? So there are two elements. So in this other row, we have to pass on same number of elements in the column, right? Let me run the program again. So you will get 1, 4, and 7, right? 1 we have, 4 we have, 7 we have, right? So this is a three-dimensional array. You see, array 3 is a three-dimensional array, and this has been clubbed with array 4, which is one-dimensional array, and we got the union of both the different type of dimensions array, right? If you notice, there is a restriction, right, on this union ID method. We cannot pass more than, you know, two arrays, right, into this method. If you take one more array, we put 16, right? If you're trying to pass on array 5, then you will get the error, right? You see, union ID takes two positional argument, but three were given, right? This is because this function accepts only two arguments as an array. Okay. Here, how we can solve this problem? So we can solve this problem with help of reduce function, which comes through the func tool module. Okay. Func tools, and we have to import its reduce function, right? This is a function. Okay. Now how we can use reduce function? So it is very simple. If I take result 3, this is my new variable. We have to call it reduce function, right? Now that would come from func tool. You see here, this reduce function will take a function as an argument, right? That would be a unique 1D, right? We have to pass on this function as an argument, right? And here we have to pass on array in terms of tuples, right? So we can say, let me print result 3 here. Okay, let's see what happens. Yeah, so this is because we have still passed array number 3 here. Let's run the program again. So you will get the output. Okay, you have now passed on more than two arrays, right? And you got the union. Okay, if you want to check what is the type of this result 3 function, which type of data it is returning, which type of object it is returning, so you will get it is returning numpy.ndarray, right? Because this function returns ndarray object, right? So this reduce function will return what this function returns. Okay, if you want to put one more, can pass on array 6. Okay, you will get the 36 also, right? Either you can do this way or you have different way to do this, right? Let me comment it out. And instead of this, you just put your element like this, 1 2. This is the same thing, right? If you run the program again, so you will get the different output, right? 1 2 5 7 8 9, 1 2 5 7 8 9, right? So this is a first case of one dimension. And if you put two dimension, right? Let's see whether it takes. Yes, it is taking, right? Okay, so we make it 19, so it will add 19 also in the output, right? See, so here we see we can pass any type of dimensions, right? And first one dimensional we have passed on, two dimensional we have passed on, right? And we have passed on multiple ND arrays, right? With the help of reduce that comes from func tool module. Okay, so we have covered how we can get the union of NumPy array, right? We have seen one dimensional array, two dimensional array, three dimensional array. We can pass down different type of dimensional arrays, right, into one function. Even we have seen reduce function wherein we can pass more than two NumPy arrays, okay, to get the union of those arrays. Guys, in this video, we will be learning how to find the unique elements of NumPy arrays in Python. We will be covering NumPy.unique function with one-dimensional and two-dimensional arrays. We have to import NumPy library first. We have to create one NumPy array quickly. Here, I have taken few elements multiple times, okay, then using NumPy unique function, okay. Here in unique function, we are expecting one array as a iterable that we will be passing on. Then we will be looking other parameters. One dimensional array here, and I will try to get the type of result one. We'll be printing elements. Unique function will return us unique element from this one dimensional array, right? Let's in the program. So you can see the type of object which unique function is returning, that is the array, and elements are 1 2 3 4, right? If we take two-dimensional array, so these are three rows for us, okay, and we have three columns, okay, and we'll be using the same function, unique function. Now this time we'll be passing two-dimensional array and result 2, and then we will print result 2, right? Okay, let's in the program. If you run it, so you will get 1 2 3 4, right? These are the unique elements. If you have taken other element, right, in any of the row, say 2, so then you will get these elements also as unique, right? 1 2 3 4 11 12, right? 1 2 3 4 11 and 12. Okay, now let's check what is the access parameter, right? If we provide access here, access equals to 0, so it will take unique rows, right? Okay, so here we could find all rows, all columns have distinct values, but let me repeat one row again, right? Okay, if you run the program, so you will see, so 1 2 2 4 is only once, right, in this output, okay, while we have taken this row as twice, okay, here and there. So access 0 means it is checking each row, right? This one, this one, this one, right? If you take axis as a 1, it will take columns, right? This way, right? This way it is checking unique. Okay. So if you say with axis 1, there is no such row column find which is duplicated. If you make one column as duplicated, let me take 1, 4, and 1, right? So we have made this column duplicated, okay, here, and we have taken x is equals to 1. Then if you're in the program again, so you will see 1341 is not repeated twice in the output. Okay, so this is how axis work. In 0 it will check row wise, with axis 1 it will check column wise. Okay, let's see how we can use return index, right? This is a parameter in this unique function. If we make it true, we will get the indexes also with the elements which are unique, right? Here return index, if I make it true, okay, so it will give me the indexes also, return indexes, right? Result when and I have taken, I will take a indexes, right? If you print the I, right, during the program, so you will get the indexes, right? Also here this unique function is returning what it is returning. It is returns the sorted unique elements of an array. There are three optional output in addition of unique element, right? Indices, input array, indices of unique array, and number of times each unique value comes up in the input array, right? In result we are getting the unique elements. In I we are getting the indexes of unique items. Okay, here if you see 0 1 3 4, right? So if you take 1 in this element, 1 is very 1 is lowest, right? And 1 is not repeated, so it took 0. Okay, then 2 2 has multiple, right? So for 2 we have one index, then we have 3. 3 is also repeated, so 3, it is for 0 1 2 3. Okay, that's why it is 3. And we have 4, and we have index is 2, right? 0 1 2 as a 4. So that is how indexing of unique element works. If you want to get the inverse of the element also, so you can use argument as 2. By default these arguments are false, which means it will take the inverse also of those elements within the program. So you will get 0 1 3 2 1, right? Means 0 means 1 is not repeated, so that is why it is taken 0. On first index we have 2, so 2 has repeated twice, 1 and 2. So index 1, and then it has taken index 1. Okay, let me print array also with the same thing, right? Array 1D. Let me make you understand once. Okay, so here if you see, this is our one dimensional array that is printed, right? And this output is our return inverse, right? It is return inverse output in I, right? So here it has taken 1 is not repeated, okay, in this 1D array. So the one index is 0. Then for 2 it has taken index as 1. Again it is 1. Okay, if you make it return inverse. If you use return counts parameter, it will show you the counts of repeated item in the array, right? So now here in I we will get the count of returns, right? If you're in the program again, so you will get, we have 4 unique items, right? 1 2 3 4, right? In the unique item we have 4 elements, right? In 4 elements it has counted the repeated element also, right? One is only only once, right? In this array, one dimensional array, and 2 is twice, 2 is twice, right? 3 is also twice, and 4 is also twice. So that's why it counted the elements which are repeated in the source array. Okay, 1 2 2 2. If I make one more element here, let me take 3 thrice and run the program again. So On 3, here you see, put one more element, different element, right? 12. Okay, let me run the program again. There are unique items. How many unique items? These are 1, 2, 3, 4, 5. So at 5 index, we have only 1 because 12 is only once in this array. Make 12 two more times here, so you will get its count increase, right? 3. So this is how return counts works, okay, with unique function. So we have seen numpy.unique function. We have seen one dimensional and two dimensional arrays. We have seen their parameters also, how return index, axis, return inverse, and return counts work. Okay. Congratulations on completing the course of NumPy library in Python. You have mastered key programming concepts. Keep coding, debugging, and innovating. The future of tech is in your hands. Don't forget to subscribe our channel for more exciting content on all things tech related. Thank you for watching and learning with us.